In this module, you will learn to differentiate between mass and weight. How much do you weigh? In our day-to-day life, we use the units kilograms for weight. This is wrong. Kilogram is the unit of mass, whereas Newton is the unit of weight. Mass of a body is the amount of matter that makes up that body, while weight of the body is the force with which the body is pulled towards the center of the earth. Thus, weight is the product of mass and acceleration due to gravity, that is, W is equal to mg. The value is approximately 10 meters per second square. Thus, if your weight scales show a reading of 60, your weight is 60 into 10, that is 600 Newton. Mass can never be zero. However, weight can be zero when the acceleration due to gravity is zero. For example, in space. In the SI system, mass is qualified in kilogram, while the unit of weight is Newton. A physical balance is used to measure the mass of a body. Weight is generally measured using a spring balance. The mass of a body is universal, meaning it remains the same throughout the universe. The weight of a body varies from place to place depending upon the gravitational force on the body at that place. This means that your mass on the Earth and on Moon would be the same, but your weight would differ, because the acceleration due to gravity on the Moon is different from that on Earth. The gravitational force of the Moon is far less than that of the Earth. That's why, before cosmonauts fly and they are acclimatized in a simulated lunar environment. This is to ensure that when they land on the Moon, they are able to move around easily, even though the gravity is reduced. Because of this difference in gravity, the weight of a cosmonaut on the Moon differs from his weight on Earth. Let's find out the difference. The mass of the Moon is 7.35 into 10 raised to the power 22 kilograms, and its radius is 1.74 into 10 raised to the power 6 meters. The mass of Earth is 5.97 into 10 raised to the power 24 kilograms, and its radius is 6.37 into 10 raised to the power 6 meters. Using the universal law of gravitation, we can find the force or weight of an object of mass m on Earth and on the Moon. By substituting the values and solving, we get the weight of the object on the Moon as 2.43 into 10 raised to the power 10 into g into m. Similarly, we get the weight of the object on Earth as 1.47 into 10 raised to the power 11 into g into m. By comparing these results, we can determine the relationship between the weight of an object on the Earth and on the Moon. Thus, the weight of an object on the Moon would be approximately 1/6 of its weight on Earth. For example, if the cosmonaut weighs 600 Newton on Earth, he would weigh approximately 100 Newton when he lands on the Moon.